Okay, now we are going to discuss the fourth question. If you haven't read it, please pause the video and read the question. The important aspect of the first part, the A part, is in terms of molecules. So you are supposed to describe this thing in terms of molecules. Why the temperature of the whole spoon increases. So we are placing a plastic spoon inside a hot liquid, and they are asking you why the temperature of the whole spoon increases. Well, what comes to my mind when I first see this question or the idea is one thing, that heat energy goes from a place of high temperature to a place of low temperature. So that idea is there. And then when heat energy is gained, it becomes the kinetic energy of the molecules, and the kinetic energy increases. So that's the second idea there. Then when the kinetic energy increases, the average kinetic energy. So when the average kinetic energy increases, it makes the temperature increase, right? So these are the 3 points that comes to my mind when I first see this question. You have a cup, you have a spoon, there's a hot liquid, and they are asking why the entire spoon becomes hot. So first, the liquid is at high temperature, so heat flows from that to the spoon. Then the heat energy is related to the average kinetic energy. So when the heat flows, the average kinetic energy of the molecules increases. A layman way of saying it is the molecules move faster, and that means that the temperature increases, right? So these are the 3 points that come to my mind. But if I go to the Mark scheme, okay, if I go to the Mark scheme, the Mark scheme also has 3 points. First point, molecules of hot liquid collide with surface of spoon. Molecules of hot liquid collide with surface of spoon. Now, in none of the points I mentioned, none of the points I was going to mention, that idea is not there. That molecular idea is not there. There is not even the mention of molecules. The entire answer is based on how the heat energy is flowing. There is no mention about molecules. We will see the rest of the answer. At the same time, the second point is transfer of energy or heat to molecules of spoon. Transfer of energy or heat to molecules of spoon. That we have mentioned. That is here. the heat energy flows from high temperature to low temperature, and that's another way of saying that heat energy is transferred from the liquid to the spoon. So yeah, we have got the second point. Let's look at the third point as well. The third point is amplitude of vibration of spoon's molecules increases or is faster, increasing spoon's temperature. Spoon's molecules are faster, increasing spoon's temperature. Now we've got that one as well. So basically this heat energy increases average kinetic energy and the average kinetic increases temperature. So these two together would account for the third point. So we looked at the question and we thought that it's a 3-mark question, and we thought that we have given 3 points, and in fact we have given 3 points, but what we missed is the molecules, the molecular idea. And if you go back to the question is phrased such that it demands you to describe in terms of molecules. So that molecular picture should be there, the molecular idea. So the hot liquid molecules coming and colliding with the molecules in the spoon, that idea should be there. Okay, so be careful about the keywords in the question. You might have the concept, you might have the whole picture, but if you don't phrase it in the direction that they are intending you or directing you, then you might not get the full marks. Still, there is something not very clear about the question and the answer given in the mark scheme. The question demands you to describe why the temperature of the whole of the spoon. We are not talking about simply one part of the spoon. We are talking about the whole of the spoon. The answer in the mark scheme has given 3 points. The first, where the molecules of hot liquid collide with the surface of spoon, which is the key beginning stage. Now, if that is the case, then if you look at the diagram, only a part of the only a part of the spoon is in contact with the liquid. Not the entire spoon is in contact with the liquid. Only this part is in contact with the liquid. So, what about the remaining part here? They're asking you to say how the entire spoon becomes hot. Yes, as far as the bottom part is concerned, the part that is immersed in hot liquid is concerned, I try to visualize the hot liquid as tea. I love tea. So, as far as that part is concerned, yes, this molecules coming and colliding is okay. But the top part is concerned, obviously the liquid molecules are not jumping like dolphins now and then from the hot liquid and hitting the top surface, right? So how is heat energy transferred from the bottom of the spoon to the top part of the spoon? Now, though the question asks you to describe how the whole spoon becomes hot, it in the mark scheme is not giving any credit or is not even answering that point. But that doesn't mean you should not address that. In fact, you should, because the question asks you to describe it for the whole spoon. So you should have gone ahead and explained how the heat transferred from the lower part to the top part as well. So how does it happen? Well, that's something that we're going to study, but just briefly letting you know, once the lower part of the spoon becomes hot, that means the atoms in the lower part starts vibrating faster. They collide with the upper part atoms, and so the lower part atoms collide with the middle part atoms, and the middle part atoms collide with the upper part atoms, basically transferring the kinetic energy. So the atoms at the bottom starts colliding with the atoms at the top, the ones which are nearby to them. Then those atoms will collide with the atoms which are above them and closer, so on and so forth. The vibration continues and the energy is transferred, and hence the top part of the molecules also receives the energy. Well, we will see all that in detail, but the point I'm trying to make here at this stage is the question is not completely answered even in the mark scheme. Okay. B part, we have to study about the thermal processes to answer that. So I didn't ask you to answer B part. So we would go to the C part. C part is a very simple direct calculation, so we can quickly do it. Whenever you are doing a question like that, it is important to extract out the information, either highlight it or first highlight it and then list it in your answer before you're using any equations. So here, so if you haven't read the question, you should pause the video and read the question. So here, the cup contains 150 grams, so that's one data. The liquid of specific heat capacity 4.2 joules per gram. Be careful about the units as well. It's not joules per kilogram per degree Celsius here, it's joules per gram per degree Celsius. And the other data that is given is this temperature difference from 80 to 56. So it's important that you kind of circle the datas before you start the question, and then what you can do is you can list the data. You can list the data. So mass is equal to 150 gram. The specific heat capacity is equal to 4.2 joules per gram per degree Celsius. Since the mass is also in gram and this is also given in grams, I don't have to change either one of them to the other unit. Then delta T, temperature change is 80 minus 56 equals, that's 24 degrees Celsius. The heat loss, simple, you just apply that equation we learned, E is equal to mc delta T, 150 times 4.2 times 24, that should give you 15,000 joules approximately.